Okay, so in this video, I'd like to implement diffuse lighting using our HDRI over in Houdini, and to do that, we're going to be using an environment light. Now, before we jump over into Houdini and actually implement this, let's discuss a few things on the whiteboard. So we mentioned we're going to be using an environment light. Well, in Houdini, an environment light really is just a type of area light that emits light from either a hemisphere or a full sphere, and we can imagine that the light is coming from infinitely far away and coming from all directions around that hemisphere or sphere, and thus we can imagine it being light coming from an environment. So let's just say that we're dealing with a sphere. Obviously this is 2D, so it's a circle, a really bad circle at that, and we've got light coming from all directions around this circle, and that will be illuminating our object. Now, by default, when we create that environment light, it's going to be emitting a single color from all directions, for example, white light in all directions. But instead of emitting a single color, what we can do, we can use our HDRI as a map. We can map that HDRI onto the light, and that's going to map the color at the different directions. For example, that may make this direction brown, this direction white, this direction blue, maybe this direction brown. So by using our HDRI, which we know represents an entire sphere in terms of direction, and mapping that onto a spherical environment light, we have now mapped the lighting such that the light that we knew was reaching a single point in space from these different directions is now being emitted towards a single point in space in Houdini from these different directions. Now, the position of the environment light has no effect on our lighting, because this light, we have to imagine, is coming from infinitely far away. So all we need to concern ourselves is that the orientation of our lighting in our virtual scene matches the orientation of our lighting in the real world. And really this is down to whoever's setting up the scene, because there's no real rule in place as to how the real world corresponds to our scene in Houdini. So at some point, someone has either matched a camera and made sure that that camera is aligned in such a way in our scene, or they've maybe built a reconstruction of the set and that is in the scene. There needs to be some defining element that specifies how the real world maps onto our Houdini scene, and then we need to make sure that the orientation of our lighting matches in with that particular definition. So by default, we may not have our HDRI, when it's applied to the environment light, oriented correctly for what we need the orientation to be for the lighting in our scene. Now, we could go ahead and we could rotate the environment light on Y, and that would modify the orientation of the lighting. The problem here is that if we then used other methods of accessing the information from the HDRI image, based down in our shader, maybe for reflections or later on for diffuse using alternative methods, they wouldn't inherit the orientation necessarily of this environment light. So we'd rotated the environment light and that would affect our diffuse lighting, but everything else would be oriented incorrectly. So a far better approach is to rework the HDRI. If we take the HDRI, we can think of orienting it by moving the HDRI. Since we know we're dealing with a sphere, if we move which pixel has a certain color to some other location in that image, we're effectively rotating the sphere, if you will. Now, by default, the lighting comes in such that the y-axis in our scene maps onto the y-axis, if you will, of our image, meaning the up-down in our scene does map directly onto up-down in our image. So we only need to concern ourselves with the orientation on X. So by offsetting, by panning the image in X, taking whatever went off the edge of the image, for example, let's say we panned our image like so, so there's now the edge of the image. Whatever was the overlap off this edge, if we take that and apply it back on the other side, since we know we should have no seams in our HDRI anyway, we've now effectively reoriented. It's the equivalent of rotating our environment light in Y to orient our lighting. We've now reoriented the HDRI, and that's now correct for our scene, so that we don't have to apply any rotations to our light, or we don't have to apply any rotational offset when using other methods of accessing that information. Now, the HDRIs that are being provided with this DVD are already oriented, and since we're not dealing with in this DVD actually matching cameras and matching a real world backplate, we don't actually need to worry about the orientation, but they have been oriented because they're the HDRIs that came from my project and I oriented them for that project. Now we also need to deal with how much light is coming from our environment light, because just because it's got the right colors, the right intensity relationships between the various directions doesn't necessarily mean that the render we get out will be of the correct exposure, of the correct intensity. Now, ideally we'd have photo reference of a grey matte light probe or sphere that was taken in our real set, in our real environment, so that we could create a CG sphere with the same surface properties and match the light intensity that way. Unfortunately, such a light probe wasn't available for me when I was working on my project, so I actually used other reference. I went out and I took a number of photographs of the motorcycle that I was matching, analyzing its various properties and how it was basically responding to the lighting conditions, and set up shaders that had the same properties and used those to get the diffuse lighting the correct intensity. But of course, the beauty of rendering in passes means that we only need to get the diffuse light approximately right in terms of intensity, because in the render we can modify the intensity in compositing, whereas we can't modify the orientation of the lighting. As long as the orientation, the directions of the lighting are correct, we can modify the intensity through compositing as long as we're rendering in passes. So with our environment light in place, and with it oriented and with the intensity and everything set up correctly, we can create a simple Lambert shader to determine the surface color with respect to the lighting, and that will give us our diffuse lighting. So we're going to be creating a VopVex surface shop. So let's say that this is going to be our shop network. So we're going to be creating a VopVex surface shop. And inside of the VopVex surface shop, we're going to create a Lambert Vop. So this is a Lambert Vop, and it has a color output. And we know that we have our, please ignore that warning there. So we have our color output, and we also have the output 1 Vop, which is allowing us to output a color for the rendered pixel. And if we wire the color output of the Lambert Vop into the CF input of our output 1, that's going to take the color from the Lambert Vop and use that in our rendering. So the light information is going to be taken into account based off of our Lambert Vop. It's then going to be used to generate a final pixel color, and that pixel color is output into the image. Of course, we aren't just constrained to having a single color for our surface in terms of the Lambert Vop. We can actually use a texture to specify the diffuse surface color, and that's what we're going to be doing. So we can create a texture Vop, take its color output and wire that into the diffuse color input of the Lambert Vop. And then of course we need to make sure that our UV coordinates are set up, and we're going to have S and T from the UV coordinates wiring into the texture Vop. So that's a very quick look at the shader that we're going to be setting up that allows us to make use of the environment light for our lighting. Now again, this is a very basic shader, hence not going into details of what it's doing. Hopefully you guys are already very familiar with creating shaders, thus should be very familiar with setting up such a basic Lambert shader. And as mentioned in the previous video, this approach actually has a number of limitations, and so in later videos we'll discuss those limitations and then discuss a multi-pass approach that overcomes those limitations. But that does take a look in overview at how we're going to approach the implementation of the lighting. So let's now jump over into Houdini and implement it. Okay, and the first thing I'd like to do before we start setting up our scene is to copy over some resources that will be provided on the DVD into a project folder for this particular project. Now, those resources include the HDRIs that we're going to be working with, along with some very basic checkerboard textures that we can use for testing purposes, and they will be in a resources folder. And if we copy both the HDRIs and textures, I can jump over to my project folder for this particular project, which happens to be in the S drive under projects under HDRI shader. I'm going to paste those folders into the root folder for my project. Then we can jump into Houdini, and I'm going to save a new file. I'm going to save this empty file under the root of my project folder simply as lesson_01.hip. So that's now got my basic file in place along with the resources. So let's go ahead and start setting up the file. Now we're going to be developing and testing this shader on a very simple scene. Obviously the important focus here is on the implementation and the architecture of the shader as opposed to tweaking shader parameters for use in terms of integration. So we're going to be using a simple scene just to get the core functionality in place, and we're not going to be worrying about actually matching an object in with a backplate, because that's really a very artistic practice that lies kind of outside of the scope of this DVD. And this simple scene is going to consist of a grid for a floor and a teapot for our focal object. So I'm going to control click on a grid from the shelf. I'm going to name this to floor, and let's turn off the grid in the display. And then I'm going to control click a platonic solid, which I'm going to call teapot, and I'm going to set the platonic solid down to a Utah teapot. Now let's make sure that we bring this up and sit it roughly on our plane. So I'm going to jump into a front view and sit this roughly on the plane. Fantastic. So this is our very basic scene. Now I do want to position a camera roughly for this scene. Let's create a new camera. So there is camera 1, and I'm simply going to go ahead and test a render of this particular view. So let's bring up a render of this view. So give that a second to calculate. And do bear with my computer as it's thinking. Obviously we are recording, and that is putting a fair strain on the CPU. So there we go, there is our scene. Notice that we have our default headlight lighting, that is the light that's coming from where we're looking. We can see that based on the specular highlight and based on the diffuse lighting of this teapot. And also notice that we've got a default specular material. We've got some diffuse here with specular highlight. So we're going to need to deal with both the lighting and the shaders on these objects. So let's deal with the lighting first. I'm going to create an environment light from our lighting shelf. So let's create an environment light. And let's take a look at this environment light. We can see some of the settings that are set on it. So we can see that our translations are locked because the position of this light has absolutely no effect on its lighting. And over on the light tab, we can take a look and see that we are indeed just an area light. We can see that we don't have any attenuation. This is where the idea of light coming from infinitely far away comes from, because we have no attenuation, therefore the position of the light has no effect. And on the area light options, we can see we are indeed an environment light. And we can also see that we have ray trace shadows, and that's going to give us the soft shadows that come from our environment. So there's sort of some basic settings that are set by Houdini when we create an environment light from the shelf. And we can, instead of using a white light color, we can actually use an area map, and we can apply our HDRI for our light color. Now, if you recall, our HDRI is a full sphere. It runs in 360 degrees in terms of our longitude, and it runs in 180 degrees in terms of our latitude. That is a full sphere, so we need to use a full sphere for the environment. And I'm going to use an area map, and let's bring this up and jump to make sure we're relative to our hip HDRIs. And we're dealing with simply the diffuse HDRI in this case. I do not want to show sequences because I don't want the number in the image to be picked up as a frame. It's not a frame, it's simply denoting the resolution of the image. And this is the 256, because it's 256 pixels wide, underscore convolution underscore diffuse dot tiff. That is our diffuse HDRI, if we accept. And then let's minimize this back down. We can now do another test render, and that will now be using our environment light for the lighting. So if I do another test render, and again give this a second to render, So please bear with my computer while it thinks about rendering. And there it goes. Well, the first thing we're going to notice is that everything is really blown out. Everything is very over bright. And that comes back to talking about we need to match the rough intensity of our light to roughly what we'd expect in our scene. Again, we can modify this in compositing, but I mean, for look dev and for testing purposes, having something this bright in our test renders really isn't useful. And since we are rendering a floating point image, an HDRI image, we can come in and drop the brightness in MPlay, and we can see that really a brightness of around 0.5 is giving us some fairly nice lighting information. So what I want to do is I want to set our light to have 0.5 of the intensity that it has currently. So we can see we do have light intensity as a parameter on our environment light, and I'm going to set that to an intensity of 0.5. We can also see we've got very low samples going on. The way the area light works, and it's one of the sort of negatives, if you will, one of the limitations of using an area light, is that the lighting is all sample based. And because of that, we have all of this speckly pattern. Now, again, we need to deal with this in a second. Now, before I do that, I do want to test the render with the light intensity, but do note we do need to deal with our samples. But if we take a look, we can see we do have generally the correct illumination coming from our HDRI. We can see that we have a strong light source from one side, and we can see that we do indeed have some softer lighting coming from the other direction, some more sort of brown lighting coming from that brown wall on the one side as well. And we can see that we've got soft shadows being generated between the floor and the teapot. So I'm going to re-render now with light intensity set to 0.5. Before I do that, let's set our brightness back to 1 so we can see the result of re-rendering. And again, give this just a second. There we go. So now we can see we're much closer to the intensity that we'd like, but we do still need to deal with our samples. Now, the way the sampling works is we can increase the samples to get a finer noise, less noise if you will, in our render, but obviously at the cost of having a slow render. Now I'm going to set this up to a value of 64 samples for the area samples. That is, again, for our environment light on the light tab. Down on the area light options, I'm setting area samples to 64. And if we were to re-render now, this is going to be a much slower render. We're going to see that we have far less of this speckled noisy pattern in the resultant lighting. Now, depending on how the encoding of this video works, you may or may not be able to see the resultant noise. There is still a fine noise there. Certainly on your systems you should be able to see this. There is still a fine noise there. We haven't increased this enough to have completely alleviated the noise, but I personally feel that the noise is small enough that it just looks like film grain in the final render. And so for me, I don't want to slow my renders down any further by increasing our area samples, so I'm quite happy to have this slight noise and just use it as if it was film grain, which actually helps in this case for the integration, as opposed to increasing our area samples, slowing down our renders and then layering film grain in over the top in compositing. Of course, if you don't want any film grain, or if you want to have complete control over that grain in compositing, you are going to need to further increase the area samples, but that is going to come at the cost of render time. Now, if we notice in this image, and it is now a lot clearer because we don't have so much noise, we are still getting specular highlights on our image, and we don't want these. We just want diffuse lighting. So we need to create that shader, the Lambert shader that we discussed on the whiteboard earlier. So I'm going to minimize our render view. And to do this, I think what I'm going to do is bring up a new network view. So new network view, and I'm going to maximize down our parameters on the right hand side just so that we can see. Let's get rid of the play bar and let's get rid of the shelf, and that should just give us the biggest area to work with. We can also get rid of the options for the network. Fantastic. So I'm going to, I do want to unpin this guy, I'm going to jump over to shop and I'm going to create a new material. And this material is going to be our HDRI underscore material. And inside this material, I'm going to create a surface shader. So this is going to be a VOP Vex Surface Shop. Wire our surface shader into the output. And I'm going to name this to HDRI underscore surface shader. So if we accept that and jump inside, so here we are inside our surface shader. This is where we're dealing with generating the final rendered colors for our surface. And as we saw on the whiteboard, we're going to be setting up a very simple Lambert shader that's simply going to take in UV coordinates specified on our surface, use those to work out the diffuse color from a texture, send that to a Lambert VOP, which will use our lighting, turn around and calculate a diffuse color based on that lighting, which we output to the output of our shader. So let's jump back into Houdini. And I'm going to start out simply by creating a Lambert VOP. And we can wire the output of the Lambert VOP, so the color output, into the CF input of output 1. And that's simply going to send a white diffuse color in terms of the surface color integrated with all the lighting that we've got going on, and the output of that is sent over to the final rendered pixel color. If we jump back up to object level, I'm going to assign this material at the object level to our floor and teapot. So there we go, assign to our floor and assign to our teapot. And if I do another test render, so I'm just going to jump into the scene view to get quick access to doing another test render, bring back up MPlay. If we do another test render, we can now see, as this guy renders, that we won't have specular highlights anymore. So let's just give this a second to render. So we're now dealing solely with diffuse lighting. If we were to switch back and forth, solely with diffuse lighting. Now I do want to wait for this to fully render. Because I want to save this image out, and we're only saving it out for comparison purposes later on. This will become very apparent when we start working on an alternative approach to setting up this lighting. This just gives us something to compare against to try and match our shader with. So I'm going to save this frame, and I want to save this frame into S, and its project. It's our HDRI shader, and I'm going to save this as our endlight underscore no texture dot pick and save. Fantastic. Let's minimize that. So now that we've got that in place, let's do another render. Again, this is going to become apparent why we want to do this later on in terms of comparison purposes. And in this render, I want to turn off our shadows. So I'm going to jump to the environment light, turn off shadows, jump back to our scene and re-render. Now this render should be a lot quicker because we're not calculating those ray trace shadows. And again, let's just give this a second to render. And this is a much quicker render. Now this is going to be almost impossible, I imagine, with the encoding to see in terms of the video, but on your end you should be able to see there is still a fine noise here, and that's because the lighting as well as the shadows are using sampling, and this is one of the big downsides, as will be discussed in the next video, of using an environment light for this lighting. You see how slow it's faster because we didn't have shadows, but it's still a slow pass, and when we go ahead and implement using a slightly different approach, we will get a faster render for the diffuse lighting on its own. But I do want to save this as well, so save frame as, and this is going to be with texture. So we can save. Let's turn our shadows back on, and then we can jump over into our shader and assign a basic diffuse surface color. So I'm going to create a texture VOP, and I'm going to grab as our texture map, let's grab from the textures folder the checkerboard.targa. Let's take the color output and wire that into the diffuse color input of our Lambert, and again re-render. And we should see by doing that that now our surface is using that checkerboard, and that checkerboard is a basic orange and blue checkerboard, nothing complicated. Take a look at the file on your end if you want to see what's going on in that file. It's really basic, and we can see that we have assigned this to our objects, but I'm feeling there's far too many repetitions here. So what we need to do, we need to set up some UVs and then make use of those UVs in our shader, again as we discussed over on the whiteboard here, dealing with wiring UVs into our texture. So there's our render. I'm going to push escape just to cancel that since we don't need that render. And let's come up to image and remove that incomplete frame. So let's jump back into our shader, and I'm going to bring in UV coords and bring S into S, T over into T of our texture. So now any UV coordinates we set up on our objects will drive the placement of our texture on the surface of those objects, but we do need to set up UV coordinates. So I'm going to jump up to the object level, and let's jump inside our floor, and I'm going to create a UV texture VOP, and I'm going to leave this with the default settings, because with the default settings we're going to be projecting down in Y, and the scale by default that we have is going to give us a nice UV layout. Let's repeat that for our teapot. So I'm going to create another UV texture SOP. Now in this case I want to use polar UV coordinates, so we get a nice sort of spherical mapping of our checkerboard onto our teapot. Y-axis again will work great for us. The scale again of 111 is going to work great for us. If we jump over into our scene view and were to re-render this, this will be the final render that we're doing in this video. We'll see that we now have a much more sort of spaced out alignment of our texture. It's a much more pleasing to the eye alignment of our texture rather than all of the repetitions that we were dealing with a second ago. So we can see that working here, and we can see how that's now combined with our lighting. So we take the color of our lighting, and we're basically specifying with the diffuse surface color, we're specifying what color of diffuse light our surface can reflect. So in terms of the orange checkered patches, we're saying we're only reflecting orange light, and in terms of the blue checkered patches, we're saying we're only reflecting blue light. What's actually going on under the hood is we're taking whatever the color that was calculated by the Lambert calculations, and we're multiplying it in with that texture map, with that diffuse surface color, to get the resultant color. And this is going to be important when we start looking at how we can re-implement this as multiple passes. But here, right now, what we're dealing with is a very simple setup. We're dealing with creating an environment light using our texture, our HDRI, as a map on that light, using that to illuminate our objects, but we want our objects to have basic diffuse shaders, no specular highlights. So we go in and we created a VOP Vex surface shop, and then we can use that to set up a Lambert VOP, which gives us that diffuse lighting model, and we're also creating a texture VOP and wiring that in with UV coordinates so that we can control the placement of the texture, but we're wiring that in to give us our surface color. So there's really nothing complicated going on here in terms of the shader. And again, this is an advanced shaders DVD, so that's why I've skimmed very quickly through the shader portion here, because this is all very basic stuff. It should be stuff that everyone is comfortable with already. I do want to save this image because, again, we're going to be using these for comparison purposes. So I'm going to go ahead and save this, and I'm going to save this out as environment light, and I'm going to save. I actually saved with texture before. What I wanted was without shadows, so I'm going to save this with texture B. Let's save. And in my folder, so where's with texture, I actually wanted that was no shadows. Oh, excuse me. There we go. And this is with texture. So in case there was some confusion, the first image I saved out was the basic lighting, no textures involved. So I saved out environment light, no texture. Then we turned off shadows and re-rendered, so environment light, no shadows. Finally, we added in our texture and re-rendered, so environment light with texture. So there's the three files. They're not of use right now immediately, but as we start implementing this, taking a different approach, we can come back and compare these files and look at how our other approach is comparing to the environment light approach. But that does complete the implementation using the environment light, and in the next video we'll take a look at the limitations of using this setup and discuss an alternative approach so that we can overcome those limitations. But with that, thanks a lot for listening, and I'll see you guys in the next video.